Welcome to section 2.4, Measures of Relative Standing. In this section, we'll shift from describing overall data patterns to understanding how individual values compare to the rest of the data set. We'll learn how to tell whether a particular value is typical, unusual, or extreme. And we'll do that using tools like z-scores, percentiles, quartiles, and box plots. Sometimes we don't just care about the value of a data point. We want to know how unusual it is compared to the rest of the group. Relative standing tells us how a single data point compares to the rest of the group. It helps answer questions like, is this score high or low? Is this person above or below average? Is this result surprising? These ideas show up everywhere: standardized tests, health reports, income rankings, credit scores, anywhere we compare individuals to a broader population. We'll focus on four major tools: z-scores, percentiles, quartiles, and the box plot. The most direct way to measure how unusual a value is to compute a z-score. A z-score tells you how many standard deviations a value is from the mean. The formula is z equals x, your data point, minus x bar, the mean, over s, the standard deviation. If the z-score is positive, the value is above the mean. If it's negative, it's below the mean. And the bigger the absolute value, the more unusual the result. Z-scores are great when comparing across data sets with different units, unlike comparing ACT and SAT scores. All right, let's compare students who took different standardized tests. Suppose Jill's SAT score is 1440, where the mean SAT score is 1050 with standard deviation of 210. To get her z-score, we're going to use that information, right? Her x value is 1440. The mean, x bar, is 1050. And the standard deviation, s, is 210. So in our z-score formula, our point is 1440 minus 1050 over that standard deviation 210. Okay, so if we go ahead and we calculate 1440 minus 1050, we're going to get 390, and we're dividing that by 210. We get 1.857. All right, so we're going to approximate that as 1.86. All right, let's change color for, there we go. Jack's score. All right, so now Jack has an x value of 31, an x bar of 21, and an S of 5. All right, so if we plug into the formula for Jack, all right, his score was 31 minus the mean, which is 21, over that standard deviation, which is 5. So that's 10 divided by 5, or 2. So that's our mean, x bar, right? One standard deviation up and 2 standard deviations up, that's a 2 times S. So Jill is right here at 1.86. She's more than 1 standard deviation up, but Jack is right here. He is further from the mean. He's a full 2 standard deviations up from the mean. He performed better relative to his peers. Even though his score, 31, is way lower than her score, 1440, right? Relative to the other people on the test, he scored significantly better. Another common way to express relative standing is the percentile. A percentile tells you what percentage of values fall below a given number. For example, if you're in the 85th percentile for income, that means you earn more than 85% of people. This is how baby growth charts work. If a baby is in the 40th percentile for height, they're taller than 40% of babies their age. Percentiles are useful when comparing positions in skewed or uneven distributions like salaries or test scores. Quartiles divide a data set into 4 equal parts. The first quartile, Q1, is the 25th percentile. That means 25% of the data falls at or below the Q1 value. The second quartile, Q2, is the median. That's the 50th percentile. And the third quartile, Q3, is the 75th percentile. The interquartile range, or IQR, is the distance between Q1 and Q3. So we would measure it by doing IQR equals Q3 minus Q1. This measures the spread of the middle 50% of the data. It's a great tool for comparing variability without being affected by extreme outliers. Now, to find Q1, it is located in the 0.25 times n plus 1 position, where n is our number of data points. Q3 is at 0.75 times n plus 1 position. If 0.25 times n plus 1 or 0.75 times n plus 1 doesn't end up being an integer value, then we're going to use interpolation to find the value in between. Let's do this with an example. Suppose a researcher records the number of hours 10 adults spend on screens each day. Now, if this data were not already ordered, the first thing we would do is order the data. But it is in order from smallest to largest. There are 10 data values, right? So to find Q1, we're going to calculate 0.25 times 10 plus 1. That's 0.25 times 11, which ends up being 2.75. All right, so I want the data point in the 2.75 position. So this is 2.5 is in the first position, 3 is in the second position. So to find the 2.75 position, we're going to take the number 3, this second data value, and add 0.75 of the distance to the next data value. So 3.5 minus 3. 3.5 minus 3 is the distance between the two data values, 3 and 3.5. Okay, so 3 plus 0.75 times 3.5 minus 3 is 0.5. So if I multiply 0.75 times 0.5 and then add that to 3, we get 3.375. That is my Q1 value. Let's find Q3. All right, to find Q3, we're doing the same thing, but we're doing 0.75 times 10 plus 1. 0.75 of 11 is 8 1/4. 8.25. So now we're going to do the same thing, right? 1, 2, 3, 4, 5, 6, 7. So this is the 8th position, and this is the 9th position. So I want 8.25. So we're going to go the 8th value, 6.5, plus a quarter more times the distance between the two data values is 7.5 minus 6.5. So that's 6.5 plus 0.25 times 1. That's just 0.25. So that's 6.75. So my Q3 value is 6.75. So now to find the IQR, we do Q3 minus Q1. So that is 6.75 minus 3.375. And if I subtract that, I get 3.385. So the middle 50% of the data lies between 3.375 and 6.75. And this is a span of 3.385. All right, let's look at this in Excel. So let's get out of here. Whoops, let's get back. Yeah, let's keep them for right now. Okay. All right, so I already have the data here. Again, it's arranged in order. If not, I would just simply highlight it and then go to my data and sort to go from highest to lowest, right? All right, now we wanted, let's go back to that data, that slide so I can see. All right, we wanted Q1. So in Excel, we are going to use the command to find the quartile. And I'm also going to show you another way to do it in just a minute, but, well, not to find the quartiles exactly, but, I'll show you exactly. So let's do Q1. All right, our command is quartile.exe. All right, so our data lies in A2 through A11, and we want the first quartile. Now Q3, let me do that as a capital Q. Q3, again, we're doing quartile. Our data lies in A2 through A11, and I want the third quartile. So now my IQR looks like that. Oh, I said 8.5. I guess I subtracted wrong. Oops, sorry about that. 3.375. Okay, so my apologies on that. I'll have to correct that. It's always good to check yourself with technology. We all make mistakes. Okay, so this is one way to find the Q1, Q3, and IQR. By the way, Q2, remember, whoops, Q2 is the median. So I could use I could use the median function. And it'll give me the exact same value as if I did the quartile and put in the second quartile, right? Because the second quartile is the median. Okay, now, the other thing that I wanted to show you is if you look right here on my data tab, click on the data tab, over on the right-hand side, I have this tool called data analysis. If you don't have that, you just load it in Excel. And the way that you load it is you go over to File, More, Nope. Oh, wait, maybe it's not file. Yeah, it should be file. Ah, sorry. There we go. Info. No. I hate it when they change versions of Excel on me. I'm looking for oh, here it is. It's up here now. Add-ins. Okay. So on this Excel, it's up here as add-ins. On older versions, you have to go to file and then add-ins. All right, but wherever it is, even if you have to put it in the search, just find where your add-ins are. Click the add-ins button. And then you, again, this one is a little bit different, right? You can just type in. So in this one, it would be analysis tool pack is usually what it's called. Well, I already have mine loaded, so it's not going to pop up for me, I don't think. But if you don't have it loaded, the analysis tool pack should be an option. You just click add, and then it automatically appears right here on your ribbon up at the top. Okay, so now if I click the analyze data, get off that. Okay, there we go. So sorry, data, and I click the data analysis. That's what I wanted. The option descriptive statistics is right here. Just click descriptive statistics. Okay. And then the input range, if you click that little whatever this is right next to here, it allows you to highlight where your data is. So just highlight the data. And then the output range, just click anywhere you want to put the output. And then make sure you have summary statistics checked. Click OK. And notice this gives you your mean, your standard deviation, your median, your variance, your rate, max, min, all of this data that we found in previous lessons as well. So that's just one handy feature is using that data analysis, okay? All right, let's go back to Excel now. Okay, and so we said, right, that this is a mistake. That should have been a 7. Okay. All right. Now that we know how to find the quartiles, we can find the 5-number summary. So our 5-number summary provides a concise description of the distribution. The 5-number summary consists of the minimum, Q1, which we just found, the median, Q3, which we just found, and the maximum. These 5 numbers summarize the shape, center, and spread of the data, especially when paired with a box plot, which we're going to learn next. A box plot is a visual summary based on the 5-number summary. The box spans from Q1 to Q3. A line marks where the median is. The whiskers stretch to the minimum and the maximum unless there are outliers. Outliers are shown as dots or stars. And box plots are great for comparing groups like test scores by section or productivity across departments because they show spread, center, and outliers at a glance. Now, here's an example of a box plot on the screen. I said the whiskers extend to the min and max, the biggest and lowest value inside the fences. So we need to know how to find the fences. Anything outside the fences we classify as an outlier. So the lower fence is Q1 minus 1.5 times the IQR. Upper fence is Q point, I messed up that slide, Q3 plus 1.5. Let's fix that really quickly. Yeah, let's keep them for right now. Oh my goodness, you did not just see that? I don't know how I messed that up on the slide. That should be a plus sign. Okay, pretend that never happened. There we go. All right, see, it's a plus, all fixed. Okay, anything outside these bounds is unusually far from the rest of the data, a potential outlier. This method helps flag unusual values in box plots and when making data-driven decisions. Let's do it with an example. All right, this time we're looking at average hours of sleep reported by 8 college students. Again, this is already ordered from lowest to highest for me, so I don't need to do that. Now, to get the 5-number summary is our first task. So we notice the minimum is the smallest number in the data set, 4.5. Q1, to get Q1, now we're doing the exact same thing before. There are 8 college students this time, right? So with 8 college students, we're doing 0.25 times 8 plus 1. So 0.25 times 9 is 2.25. So 1, 2, so we're going 5 plus 0.25 times 6 minus 5. That's a 1, so that's 5.25. Now the median, 1, 2, 3, 4. 1, 2, 3, 4. So we're averaging those two. 6.5 plus 7. 6.5 plus 7 divided by 2 is 6.75. So my median is 6.75. Q3. All right, now we're doing 0.75 times 8 plus 1. And 0.75 times 9 is 6.75. So 1, 2, 3, 4, 5, 6. And then 0.75 times 8 minus 7.5. Right? The 0.75 from here is what's going there. And then the 8 minus 7.5 is the distance between those two data points. So 7.5, so we're doing 8 minus 7.5, multiplying that times 0.75 and adding that to 7.5. We get 7.875. All right, max is like 10.5. That's our highest data value. There's our 5-number summary. Now, it's also going to help us to have the IQR because we got to get fences. So my IQR is Q3, which is 7.875, minus Q1, which is 5.25. So let's do that. 7.875 minus 5.25 gives us 2.625. All right, so Q1 minus 1.5 times the IQR, and my IQR is 2.625. is going to be 5.25 minus 1.5 times 2.625. So my lower fence is down here at 1.3125. That's the lower fence. Okay, so that's 1.3125. All right, let's call that 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, because Q3 plus 1.5 times the IQR 2.625 would be Q3 is 7.875. $7.875 plus 1.5 times 2.625. 11.8125. So right here, 11.8125. That's where my upper fence is. Okay, so Q1's at 5.25. 5.25 puts a box here. The median's at 6.75. 5, that's 6. So 6.75 would be right about there. And then Q3 is at 7.875. So 5, 6, 7, this is 8. 7.875 should be a little bit before that, right? So now we draw our box there. There's our box. That, imagine those are straight lines. This is supposed to be a straight box. All right, now we go down to the lowest data point inside the interval. That's 4.5. Put our whisker there. The biggest inside the interval is at 10.5. So put our whisker there. We have no outliers. Oh my goodness, all that work. Let's see how to do it on Excel. So let's keep for now. Okay, so here's our data set that we just looked at. All right. So I already showed you how to get all of the Q1, Q3, median, all that. Now I'm just going to show you how to do the box plot. We're going to highlight the data values, insert, recommended charts, all charts, box and whisker. And once again, we can change the chart title. This is sleep per night. And we can add our axes titles on there. We want to say this is the number of hours. But here's the important thing. You can read all these values right off of the chart. If I click the line here, notice if I hover over and there we go. Value 4.5, that's my minimum. Get the value on the box. Come on. 5.25, that's my Q1 that we found. Median 6.75. Q3 7.875. Maximum. Gotta hover right. 10.5, right? So I can read all of that directly off the box plot. Okay, so to summarize, z-scores tell us how far a value is from the mean. It's useful for comparison. Percentiles and quartiles rank values and divide data into segments. The IQR measures the spread of the middle 50%. Box plots give a visual summary and flag outliers. Together, these tools let us see how individual data points stand out or fit in, and help us to compare people, performances, or outcomes across many settings.